Hello, this is the demonstration of my multiprocessor for ECN 160. Take off the clear and turn on the clock. So you'll see it's printing out some ASCII text, and then it's going to do an addition, multiplication, a software subtract, and then a hardware subtract. So walking through the different pieces, we have the counter. Incrementing by 1 goes through each address line in the PROM where there are instructions in hexadecimal that will produce 8 binary bits. The 4 most significant bits will go to the instructional decoder, which also have instructions and will pass through to these 8 binary bits that will determine what we do, either with the MUSC, the register file, the ALU, where it will do logic. The 4 least significant bits will go into the MUSC and pass through to the register file. So inside the register file, we have 2 registers, register 0, register 1. We have our address line that will determine whether we're writing to 0 or 1, and we have the write line to write into the register. So we have our 4 registers inside with a 1-bit register that's loadable inside of that. Going into the ALU, we have our adder, OR, AND, and XOR. 8 binary digits being passed in. We have 4 for A and 4 for B. That can have some logic done to it. Depending on the select line, 1 will pass through to the accumulator, where this is also the 4-bit register that we've seen before that will store that digit. And then the instructional decoder will determine if that gets passed back into the register file. So in our adder, we have a hardware subtract with those 8 binary digits again. The hardware subtract can do the 2's complement, so implementing that hardware subtract. We also have our bitwise XOR, OR, and AND. And inside the adder, we have our 1 full adder, 1-bit full adder. So back at the top level, go over how the hardware and software subtract were implemented. So it was implemented by passing the number 3 into register 0, and then passing all the digits, so 15 into register 1, and then doing the XOR to get the 1's complement of the 3, passing that back into register 0. Then we get 1 into register 1, do the addition of 1 and the 1's complement of 3, which will give us the 2's complement, pass the 2's complement back into register 0. And then we have the number 4 passed into register 1, do the addition of the 2's complement of 3 and 4. That addition pass back in the ASCII number needed for the display, and then display to the text, to the screen. So the hardware subtract was simpler. We just needed to trigger the byte for the hardware line, and that did the 2's complement and got us the same answer. Thank you so much.